So first we are going to find the torque and RPM pair for the max speed. So what is the max speed of the vehicle that I want to go? So let's come to the vehicle input sheet, and then I have defined the max speed of the vehicle should be 110 kmph. Let's come back to this fun with vehicle dynamic sheet. So what I want, this the max speed or V infinity speed or the constant speed 110. When the slope of the road, of course it is 0. So when I do that 0, and let's say my motor torque is 50, then I got 188 kmph. I need to little bit reduce this motor torque. So let's go for 40. Then I got 165. I need to achieve 110. So what I will do, I will go, let's say 50. I got 86. Now I have to increase it. So see how many iteration basically we are doing it. And to avoid this pain, Excel sheet has given amazing tool. Just come to here data, and then you will see this what if analysis. So just click here and then click on the goal seek. So he will ask for the set cell. What is the cell number? Which is C17 here. To value, what value that I want? I want 110 by changing which cell? By changing the torque cell here. So I will just click here and just click OK. So I got the torque value, which is 20.7295. At this torque I can get this max speed, which is 110 kmph. So this tool is very helpful, and we will be using the infinite times this tool. So please get familiar with this tool. So we are done with this driving mode. So what is the motor RPM? So motor RPM at 110, as you can see here, is 11294. So I will write here 11294. What is the torque? Torque is nothing but 20.7295. So 20.7295. And then what is the power? It is just the multiplication of this, but instead of multiplying it, I will just take this value from here, which is 24.52. So I will just going to write 24.52. So this driving mode is done. So in order to drive at max speed 110, I need a motor torque which is 20.7295 Newton meter. Now let's go to the next set of torque and the RPM pair, which is for rated mode. So what is the rated mode that we have already discussed? When the vehicle is going on the continuous inclined road, which is around 5 degree with the constant speed, let's say 60 kmph, that is we call a rated mode of the vehicle, or similarly the rated mode of the motor. So let's come here in a vehicle input sheet. What we have defined for continuous operation, which is the hilly road, the speed should be 60 kmph and the gradient of the road should be 5 degree. Let's come back to here, fun with vehicle dynamics. So slope, I need 5 degree, which I will put it. Now the torque, which is here 20 Newton meter, is not sufficient to even hold the vehicle. What will happen at this torque? The vehicle will start going down instead of going forward. So I need to increase this torque. So let's increase till 50, and then see everything is now come back here. So at this 50 Newton meter torque, I am getting 100 kmph. But how much do I need? Just a 60 kmph. So we will take the help of our friend, which is the goal seek. I will come here, what if analysis, under the data tab, and I will just click the goal seek, and the value what I need 60 kmph by changing this torque value. Yes, I got the 60 kmph by changing this motor torque, and the value that I got 41.94, or roughly it is just 42 Newton meter. So let's fill this table here. For the rated mode, the RPM, how much the RPM is there? 6160. 6160 motor RPM. The torque that we got 41.9, and just going to write 42. And then the power, we can just take it from here, or you just multiply this and this term, but make sure to convert this RPM in a radian per second. Okay, but I will take this value, which is 27.06, or roughly 27. I will write here. Now this is the rated mode, and then at the start we will explain later what is going to be at the start. Of course, the RPM will be 0. The torque, what would be the torque at the start? It will be the same as this 42 here, and then the power definitely is going to be the 0. So I'm going to explain in a graphical or visual way why I have written something like this. So now let's go to the peak mode of operation.